So welcome to lesson 3.2. This is an overview of it. We're going to look at balancing blood alcohol. So the general theme is working with formulas. And so here's a formula that allows us to guess at, not guess at, but calculate based on some variables someone's blood alcohol after consuming some alcoholic beverage. So B is the percent BAC. That stands for blood alcohol content. BAC is actually a percentage. So let's take, for example, suppose someone's BAC, or just B, we claimed was 0.1. So that's above the legal limit. What that really means is 0.1%. So we might say 0.1 or 0.08, but it's really 0.1% or 0.08%. So percent means divide by 100. Okay, so then this is equal to 0.1 out of 100. So that's how you convert a percent to a regular number. Well, dividing by 100 shifts the decimal point over, so I could say, all right, that's 0.001. And if I read that by identifying the place values, I have tenths, hundredths, thousands. That's the same thing as 1/1000th. So if someone has a BAC, a blood alcohol content of 0.1, that's really 0.1%, which is 1 out of 1,000 of what? Well, turns out this right here is grams of alcohol, and this down here is grams of blood in their system. So for every 1,000 grams of blood in their system, there's 1 gram of alcohol at that point in time. There are a lot of variables related to blood alcohol content. The most significant ones are the number of drinks you've had, the amount of time that's gone by. Also significant is how big a person is, what's their weight, and it turns out there's a slight difference between men and women. So we're going to look at an example applying this formula to a situation. So let's take, for example, a woman. So that means we're going to use this gender factor down here on the bottom. And let's have their weight, W, be 140 pounds. And let's say that the number of drinks they had how about 4 standard beers, like 4 buds maybe. And what we want to do is take a look at how this woman's blood alcohol content is going to appear over time after she finished drinking those 4 beers. So I'm going to use a spreadsheet as a calculator here to work that out. So let's hop over to my spreadsheet. And I've already entered in that I have a female, so we're going to use the gender factor of 0.55. The weight's 140 and they had 4 drinks. So we can simplify a little bit. If you look back at the formula, this N, W, and G all fit together to give this number right here, and then T is going to be our time in hours that's just going to go by. So let's make that calculation. So I'm just going to make a note down here that I'm going to figure out let's see, is it 84 or 48? It is 84. 2.84 times the number of drinks divided by parentheses the weight times the gender factor. And so over here I'll make that calculation. To make a calculation you have to type equals first. So I have 2.84 times the number of drinks. Now, since that number already appears on the screen, I don't need to type the 4. I just go click on the 4. Divide. I need parentheses because the denominator is complicated. You could say I need it in the top too, but it turns out it doesn't matter in this case. And I can demo that in a sec. So let's see, we want the weight next. So again, I don't have to type the 140 again. It's already on the screen. I just click it. And the computer says, oh, you want the number in cell B2. And then multiply by the gender factor and close parentheses. So I'm just going to double check that calculation by being more careful with parentheses. What if I put parentheses around the numerator? Because it's complicated, that's always a good idea. Times the number of drinks close parentheses, divide, start the denominator with a parentheses, weight times the gender factor, close parentheses. And you can see I get the same exact number. If I try to do that completely without parentheses, and things aren't going to go my way. So 2.84 times the drinks, and let's suppose I do a divide, but I don't put a parentheses, and I take the 140 times the 0.55, I get a different number that time. So parentheses matter, and part of this class is getting used to how to apply the order of operations when using a calculator or a spreadsheet. So I'm going to delete that last one, and I don't need this one. I was just playing around. All right, so I could simplify the equation by rounding that a little bit. Let's suppose I went to 3 decimal places, blow that up a little more, and I can ask the computer to display less decimals for me. So to 3 decimal places, we could call it 0.148. So I'll come back to the spreadsheet in just a sec. So for this particular woman, I could rewrite her equation by saying her blood alcohol content is going to be equal to negative, oops, pen troubles there, sorry about that. Try again, come on. Negative 0.015 times the time, and then this whole fraction, we cleaned that up a little bit by calculating it, is going to be about 0.148. So this is what the equation would look like for that woman, and we could look at it by plugging in numbers, which I'm going to do on the spreadsheet. So back here. So next what I want to do is, let's go off to the side here. I'm going to make time here, column, and time is going to be in hours. We should always label what we do. And this is the person's BAC. And so right when they start drinking, that's 0. And then 1 hour, 2 hours, 3 hours, 4 hours. And this equation is a little fuzzy at the beginning, and we can talk about why in just a moment. So let's see. It's always going to be equal to equals negative 0.015 times the time. Well, the time happens to be located right next to me, so I click on the time I need right there. And then plus, I'm going to add on that 1.48. And you might be thinking, oh, oops, sorry, 0.148. Why would I type that number here instead of just clicking on it? And that's a little tricky. I'm going to wait to show you that in a minute. I'm just going to type it for now. And the equation is pretty much always the same. Down here I would type equals negative 0.015 times, now the time is right here, and then I add on that 0.148. Enter, and it reduced a little bit. Okay, so that 0.148, that turns out to be like her initial alcohol content. So that would be 0.148% alcohol in her bloodstream, given her total amount of blood. Just a slightly different way to look at it, I pretty much used the same formula here, just same numbers multiplied by that time, same numbers multiplied by that time. So a slightly different way to do it, and note I have a 0.133 here, I'm going to delete that. Once you type a formula, you can often reuse it by just filling it in a particular direction. Now, if you type it right, it'll fill properly. Notice I got the same number here, the 0.133. If you don't type it right, then things might not work. Okay, so notice I have 0.133 there, 0.118 there. So I'm going to delete this and try again. So earlier, I had typed the negative 0.015 because that's not anywhere on the screen, multiplied that by the time that is next to me here, and then I want to add on. Now I want to add on this number. The problem when I fill this down is the computer is going to turn that D2 when I come over here to a D3, and that's good. I do want to grab the next time and then D4 and D5 and so on. However, it's going to change this B4 to a B5, but there's nothing in B5. So check this out. That's an idea called relative cell referencing in a spreadsheet. All right, so those aren't the numbers I had before, so something went wrong. All right, so what went wrong? If I double click this, it did grab the right time, but since I shifted the whole formula down, it shifted that cell reference down too. So there is a way to trick it into not messing with your cell references. And the trick is to flag things with a $sign. So in my formula here, the D2, I want that to change each time to a D3 and a D4 and a D5. But that B4 always has to stay B4. So the trick is I put a $sign in front of the 4, meaning don't touch that 4. Meaning when I fill this up or down, stay in row 4 here. That's the right number all the time. So I'm going to hit enter, try this again. So you hit enter on the formula, click back on it, then point to the bottom right corner. That order of operations is important. You get the pointer and then you get the plus. When you get that plus, click and drag down. And if I pick one of these other ones, there we go, there's that 0.118 I had before. If I double click on it, it says, okay, I grabbed D4 for you, so it shifted that down twice, which was appropriate, and it did not mess with the B4 because I said $4, don't mess with the 4. So the computer reads this left to right, sees the $sign, says don't touch what comes next. Okay? It didn't bother changing the B. It'll only change the letters if you copy something left or right. So anyway, now I can see for this particular woman that if she drinks 4 beers in a row, 4 hours later, she's still not above the legal limit for operating a motor vehicle. Okay, so this woman drinking 4 beers in a row is not a good idea. She's going to be fairly intoxicated at this point here, and she's going to still be under the influence 4 hours later. If I want to fill this down, I can fill this formula by just dragging it down a couple more. Notice nothing changed. That's because there's no time here, so I got to fix that. To fill down the time, since that's just numbers, not formulas, I need a pattern of 2. So I highlight 2 of the numbers, and then it'll say, oh, you want 5 and then 6. Now it recalculates. So I can see 5 hours later, she's just barely under the legal limit. 6 hours later, she's reasonably under, but still I think that's a little sketchy for driving. So this gives us, again, the opportunity there. Now, whoa, sorry, I hit some wrong button. Maybe the woman thinks, oh boy, I better not have 4 drinks in a row tonight if I want to drive 4 hours later. She says, well, what happens if I only had 3? Nice thing about the way we did this spreadsheet is we can plug a 3 in there and it'll recalculate everything for us. So we could see here, 3 hours later, she'd be technically under the legal limit according to this particular equation. All right, so that's example number 1. We're going to play with another example. Suppose instead of measuring, given a number of drinks, measuring the blood alcohol content every hour, what if instead we play around with the number of drinks at a particular time later? So let's stick with that same female. So we use that 0.55 number. If it was a male, then we would use 0.68 as the gender factor. We're going to, let's see, what else do we need to know? Weight. That's going to be still 140. And this time we're going to fix the time. So the time, we're just going to say, well, what's going on 3 hours later? Okay? And then we'll let the number of drinks vary. So let's write that down on paper. And anytime I use a spreadsheet, I'm going back and forth between a piece of paper and the spreadsheet. So here's my paper. So we have a new scenario. So in this new scenario, again, we have that woman, and she's 140 pounds, but we want to know what's going on at 3 hours. So remember our equation, B equals negative 0.015 times the time plus that 2.84 number times the number of drinks all over the weight times the gender. And technically this big fraction bar here means that there's kind of a hidden parentheses, meaning you got to do that calculation and that multiplication before you can do the division. Okay, so in a calculator, we have to use the parentheses. When we write pretty math stacked like that, we usually don't write those red parentheses. All right, so let's plug some stuff in here. What do we got? Her blood alcohol content, negative 0.015. Now here we're plugging in 3 hours. So now this part is constant, but the n is going to be my variable, right? So I'm going to get 2.84 times n, and I don't get to plug anything for n in yet. And in the bottom, I'm going to have 140 times the gender 0.55. Now, a kind of cool thing about the way fractions like this work, I can isolate these numbers right here and make that calculation, then just multiply it by n. So let's do that on the spreadsheet. So on the spreadsheet, I want to know what happens if I take that 2.84 number and I divide it by parentheses 140 times 0.55. Now, since I didn't put in equals, it's not going to calculate anything. It's just going to leave that there. So I'm just making a little note for myself about what the heck I'm doing. 2.84, because otherwise when I look back at this later, I might be wondering, what was I doing? Times 0.55. Okay, so that number is about 0.037-ish. Let's round that a bit. 3 decimal places hopefully is good enough there. So let's clean up our formula. Oh, we also have to take 3 times that right there. And I think I can do that in my head. All right, so cleaning this up a little more, we get, oops, let's use blue, that the blood alcohol content is going to be, let's see, 3 times 5 is 15, 3 times 10 is 30, so that's a 45. So negative 0.045 plus 0.037, I believe is what we calculated, times n. And so if the person has no drinks, this says she should have a negative blood alcohol content. That's kind of weird, right? If we plug in 0, 0 times 0.037 is 0. So I could kind of start my table here for, let's see, number of drinks versus blood alcohol content 3 hours later. So if we had no drinks, we have a BAC of negative 0.045, which that seems impossible. Oops, I want that to be red. Come on. Uh-oh, my pen's broken. Oh well. If we went 1 hour later, we would have a subtraction of these two, which appears, did I make a mistake here? Is that still negative? Huh. All right, let's double check with the spreadsheet that I didn't mess this up. I think I plugged that stuff in right. Okay, let's go back here. Times the number of drinks. That looks okay. And that looks okay too. All right, well, let's make a table and see what happens. So we have number of drinks, and we have BAC. And time we're fixing at 3 hours later. Oh, it's the 3 hour thing that's messing things up, right? Okay. So 0 drinks, 1 drink, 2 drink, 3 drinks. Yeah, that does make sense. All right, so I'll explain why. Let's do the calculation. Equals negative 0.015 times 3, and I'm just going to put a 3 in there for now, plus we have our 140 times the number of drinks, which is here now, divided by, now I need parentheses, and I want the weight, 140, times the gender, 0.55. And again, I could click on all of those numbers, but then I need a lot of dollar signs to make things stick. So I'm just going to do this for now. D2 is my variable. It doesn't need any dollar signs. All right, enter. Yeah, and at first, 3 hours later, this formula isn't relevant anymore. If she had no drinks, it's definitely not relevant. If she had 1 drink, Oops, that's weird. No, maybe that's okay. Oh, no, that's way too big. All right, definitely have an error in the calculation here somewhere. And, oh, I put the weight up there. That doesn't go there. That's supposed to be the 2.84, right? Okay, that's better. All right, so there's the negative number I was thinking we were going to have. And just double check that on paper. Next page. Again, math is kind of a sport. You have to play around with numbers. If I plug n equals 1 here, then essentially I'm going to have these two numbers subtracted, and the answer is going to be negative because this guy is farther from 0 than that guy. So I'm just going to write 0.045 minus 0.037. And subtracting here, there we go, we'll have to borrow. And 15 to 7 is an 8. 3 minus 3 is 0, 0, 0 point. And then since the 0.45 is actually the negative one, then this answer should be negative. So I should get about negative 0.008. Remember this, oops, that number there was rounded. So spreadsheet says, yeah, negative 0.008. Okay, so we're looking better. And again, using a spreadsheet, you got to double check on paper sometimes if you're using it right. And let's decrease the decimals. 3 should be good. So this is only going to be relevant if she has 2 drinks or more. Otherwise, we get these nonsense answers here. So I'm going to highlight those. Say, hey, flag, something was weird about those. So the formula doesn't really help there because it can calculate negative BACs, which physically don't make sense. Okay, so to fill this down, I can highlight these 2 rows and drag it down a little bit. Okay. So I can see if this person has 2 drinks or less, 3 hours later, they're fine to drive. 3 drinks, we're getting close to the legal limit. 4 drinks, 3 hours later is not enough time. 5 drinks, 6 drinks, right? Definitely trouble. Interesting thing to note over here, how these numbers are changing. So I'm just going to highlight these guys and graph them. Can you guess what the graph is going to look like? Is it going to curve, like some of the things we saw before, or is it going to be straight? Zoom out so we can see it. Look at that. They line up perfectly. Okay? So let's pull that out of the way and just double check. So remember when we were playing with patterns? Come on, computer. There you go. I know things will line up if these numbers change by the same amount. These numbers over here should also change by a fixed amount. So if I say, all right, what is this second number minus the first number? I get 0.037-ish. And if I say, what is this third number here minus the one before it, I'm going to get the same thing. So consecutive differences here are always the same. That means stuff's going to line up because the consecutive differences on this side, I'm jumping by 1, right? Then I jump by 1 again. Then I jump by 1 again. So this over here is my rise, and this over here would be from 1, jumping by 1, that would be my run. So my slope is actually this number right here. And so the next lesson is more about, the next 2 lessons are more about slope. Okay, so those are a couple problems that you're going to play around with in this lesson. I just want to come back to what BAC means again. So new page. So let's suppose somebody has a BAC of 0.095. What does that mean? So remember, BAC is really a percentage. So we leave off that percent, but it's supposed to be there. So I'm going to put it in right there. Percent means divide by 100. So that would be 0.095 divided by 100. A couple ways to deal with this. I could divide by 100 by shifting the decimal point. So that would give me 0, 0, then 0.95. Another way to look at that, you're going to be asked some questions where you're asked to state the grams of alcohol per 1,000 grams of blood. So here I have a fraction over 100. If I wanted that to be over 1,000, I could multiply top and bottom by 10. So I would take that 0.095 divided by 100, multiply top and bottom by 10. That means I get to shift the decimal point this way. And so I would get 0.95, so just under 1 gram of alcohol per 1,000 grams of blood. So that's grams again of alcohol, and this is grams of blood right there. Let's try another example. Suppose somebody had a BAC of 0.14. Let's just do 14. That really means 0.14%, which I can look at in a couple of different ways. I could say, hey, that's 0.14 out of 100. If we multiply top and bottom by 10, that would be 1.4 grams of alcohol per 1,000 grams of blood. And again, you're going to given some questions where you're asked about 1,000 grams of blood. Some people don't like a decimal on the top, so I could say it's 14 grams of alcohol per 10,000 grams of blood. And so there's a lot of different ways of looking at that. All right, so big ideas here are using formulas, that there are many useful formulas out there, and we have to often make some assumptions and simplifications so that we can actually make a situation studyable at a certain level. And then in this case, another big idea is the idea of continuous change that's constant. In this case, we have things that line up, and that's going to happen in a couple of different instances with blood alcohol level. All right, that's it for now. Stay in touch, do good math. Bye-bye.